All right, welcome back, everybody. So, we've got a very exciting keynote coming up, but first I want to make a quick announcement. So especially thanks to Aurélien and the other local organizers for putting together an amazing social program. So hopefully everyone enjoyed the museum who could go. We had the treasure hunt yesterday, we had the dinners. Now the treasure hunt, we had a decisive victory by one team. In fact, it was composed of all the former Colt PC chairs. And they did really well. They did suspiciously well. Because, a lot of the younger teams were like running between the different, sites for the treasure hunt. But this team, Aurélie and I decided to investigate. And it turned out that they had an advantage. So they had a mechanical advantage. They'd harnessed some device that augmented their speed, called a bike. And, while it wasn't explicitly against the rules, it calls into question the very nature of, whether this was fair and the legitimacy of their win. So we decided, even though it wasn't explicitly against the rules, to give them a certificate. But it says treasure hunt winners, but maybe cheaters. So Sasha, Nati, Vitali, were there any other people on your team? Would you like to come up and take a picture? Ohad, come on. Do you guys need a bike to get up here?
The guide, we'll take a picture. The guide told us to do it.
Do you have anything you'd like to say?
We'll have some tools.
I don't think an acceptance speech is appropriate.
We made good use of tools.
Right, okay.
Use the tools that you have.
Yeah.
All right. Ohad, your name's not on there. We'll pencil it in. All right, so Nika's going to do the introductions, and so Nika, first take it.
My name is not.
We'll pencil it.
We don't hear you, Nika, if you're supposed to be heard.
Let's see, Aurélien. Okay. Well, I'm glad to hear about the past Colt program chairs upholding the integrity we are all known for, and congratulating them. But let me start by saying that it's my pleasure to introduce Katrina Ligett. Katrina is a professor in the School of Computer Science and Engineering at Hebrew University and is the academic director of the Interdisciplinary Fetterman Center for the Study of Rationality. Before joining Hebrew University, Katrina, for many years, was at Caltech, and we were very sad to see her leave the US and be a little bit farther from us. Katrina's work, of course, has been really influential in a lot of different fields, including privacy, fairness, and broadly the theoretical underpinnings of how we think about learning and economics. She's received a lot of recognitions for her work, including an ERC Consolidator Grant, an NSF Courier, and Microsoft Faculty Fellowship. She's also been the program chair for our sister conference, ALT, as well as program chair of Symposium on Foundations of Responsible Computing and the current general chair of the ACM Symposium on Computer Science and Law. We are so excited to have Katrina. We were really excited that she accepted to get our invitation to give a talk at Colt, and are very much looking forward to her talk and learning how data might be more similar to the apple we eat, it turns out, compared to the music we might be listening to on Apple Music. Of course, I wish I was also sitting in the room next to you guys to listen to her, rather than being stuck in the US, but I'd get up at 3 a.m. to listen to Katrina talk any day of the week. Well, without further ado, Katrina, please take it away. We're really excited about your talk.
Great, thanks so much. Thank you, Nika. That's actually really a particular honor that you are up so early to join us today. And I'm really sorry that you're not here in person. So hi, everybody. I'm Katrina Ligett, and today I'm here to talk about really a pretty broad range of work, much of it not my own. The parts that are my own are really spread over a wide range of topics, but most recently I've been doing some writing related to sort of the more legal and policy aspects of what I'm going to talk about today with Kobe, Ayelet, and Saad, whose names are mentioned up here briefly. So today, basically, I'm coming here with what I think is kind of a provocative claim. I want to convince you that you've been thinking about data wrong, that we've been thinking about data wrong, and that wrong thinking has consequences. I want to try to explain what's been wrong with our thinking, and I want to share some alternative ways of thinking about data. This argument is going to be informed by 3 different fields: economics, foundations of privacy, and a more statistical perspective. And so to get started, I want to sort of fill in some gaps and set some vocabulary for us. And is the microphone not working for us all right, like this? People in the back, do you hear me? Okay, I think we're all right, but thank you, I appreciate it. Okay, great. So I have this claim, actually data is a rival good. So first, we need to establish what's a rival good, and maybe before that, what is a good? So a good is a thing, an item, a service, sometimes concrete, sometimes abstract, that satisfies some human want, provides some utility, some usefulness of some sort. It's a very general concept. And in particular, the concept of a rival good was introduced by Elinor Ostrom, Nobel Prize winner, and Vincent Ostrom in '77. And the concept here is a rival good is something that can be possessed or enjoyed only by one consumer at a time. So maybe the classic example here is an apple. If I eat the apple, you cannot also eat the apple. But also things that are not necessarily consumed or destroyed. The scarf, while I'm wearing it, would be rather awkward if you were also wearing the scarf. The book, while I'm reading it, you cannot also be reading it. Or the seat on the airplane for a particular flight. I would really prefer you try not to occupy it with me. We also, sort of on the other end of the spectrum, have non-rival goods, things like digital services. If you're listening to a song on Spotify, it doesn't bother me at all. I can listen to it as well. Fireworks display, I can enjoy it just as well if you're also enjoying it from your yard. Radio broadcast, the fact that you're listening in your car does not in any way impede my enjoyment in my car. But also things like public services, the fact that there's good lighting on our street, the fact that we have good public defense are examples of sort of classical non-rival goods. It may seem that non-rival goods are very abstract and rival goods are very concrete, but also rival goods can be rather abstract as well. So for example, if we think about radio spectrum, if I'm broadcasting on a particular band of radio spectrum, you cannot also be broadcasting on that band of radio spectrum. We can go even to the far other extreme and talk about anti-rival goods. These are things that just get better the more people are using them. A natural example might be natural languages or computing languages. These are just more useful the more people can understand and interoperate with them. But also many technologies that we use, whether they're for communication or other forms of connection, they just get better the more people are using them in general. Okay, so now we should be sort of on the same page about what do I mean by a rival good. I want to line this up with another concept that we use to talk about different types of goods, which is that of excludability, in part because it'll come up as we go along through the talk, and also because it's a little confusing how it interacts with rivalrousness. So we here have rivalrousness. This is the question of whether the good can be possessed or enjoyed by one consumer at a time, more than one consumer at a time. On the other dimension, I want to put excludability. And this is a measure of the degree to which some supplier or managing body, somebody can prevent the consumption of a good, how much we can sort of control that. The dimension that feels most natural to me here is the combination of rival and excludable, or non-rival and non-excludable. So there, it's quite natural to think of lots of examples of things that are rival and excludable. Like that apple, not only if I'm eating it, you cannot also eat it, but we have various means, both physical and legal, for preventing you from taking that apple from me. sort of on the other extreme, something like radio broadcast. I can enjoy it, you can enjoy it, it's all good. And also, without introducing some additional technologies or restrictions, there's nothing to stop you from listening to it in your own car whenever you want to. Perhaps a little bit less natural is sort of the opposite diagonal here, where, for example, we can talk about non-rival and excludable goods. So if we were to introduce some additional technology, like encryption in our radio broadcast, we could prevent people from using it. And there we get to things like cable TV, where we have no harm to me from you watching a show while I'm watching a show, but actually we do have some technological means to prevent non-subscribers from accessing it. And the hardest cell to fill, and if you have a better example than mine example, feel free to tell me, are situations where the good is rival. For example, there are a limited number of fish in the lake, and so if people overfish, there will not be fish for me to enjoy. But it's hard or infeasible to really prevent people from using the good. It's a big lake. It would be really sort of unreasonable to build a fence around it and really stop people from getting to it. Okay? So, of course, as you've already been thinking in your heads, these are kind of silly extremes, and the world is not black and white. So I said that that book was rival, but of course it's not 100% rival, because I can look over your shoulder while you're reading. And I said that that spectrum, that radio spectrum for broadcast was rival, but it's of course not 100% rival, because I can broadcast weekly on your radio spectrum maybe from a different town or a different part of the world. I said that that fireworks display was non-rival, but of course it's not entirely non-rival, because a million people standing right in front of me could block my view. And I said that those streaming music services were non-rival, but actually too many Taylor Swift fans could exceed our bandwidth capacity and bring down the network. So rivalry is on a spectrum, and maybe the sort of less catchy version of the title of the talk should have been something like, actually, others' use of data affects what you can do with it. So it may be a little bit untraditional, but one way that I think about rivalrousness and what it's introducing for us in the context of data is I think of it as introducing a negative externality. But of course, negative externalities from others' use of data is nothing new. There's nothing surprising about the idea that me using data could sometimes make you worse off in general. For example, in the context of privacy. What's special about the argument that I want to make today is it's a particular form of negative externality. So I want to argue that my use of data should at least sometimes make you worse off in a particular way. It should make you worse off by making that data or other related data less useful to you. Okay? What do I mean when I say data? I mean kind of the most general notion of data. I don't want to get too specific. It can be structured, unstructured, whatever you want, all different kinds of things. What matters to me is that data is something that encodes insights. It can encode lots of different kinds of insights. It could be insights about individuals, about groups, about society, about the world, about nature. It can be insights about business opportunities, scientific discovery. But data is there and interesting to us because of the insights that it encodes. Okay. So hopefully you understand the concept of rivalrousness now. And now the question is, okay, I'm going to argue to you that data is rival. Why should we care? Why is this going to matter? And I'd argue that if data is rival, or at least sometimes should have a rival nature, that can change how we could or should use it. It increases demand for new algorithms that might use data sparingly, that might track data usage. It changes how we value it, how we transact on it, how we buy and sell. It changes how we share data, with whom we share it, both within and across organizations. And it calls for new measurements, new models, new technologies. And there are a huge number, I think, of rich open questions, some of them very cult-flavored, some of them having sort of projections into many other communities. And fundamentally, as I'll argue towards the end of the talk, if you buy this rival nature of data, it potentially gives us a push to change our approach to science. Okay, but I said this was a sort of provocative claim, Is anybody actually claiming the opposite? Or do we really go around thinking the data is non-rival? So one answer to this question is yes. Open the American Economic Review, the top journal in economics, and find yourself a recent paper with the title Non-Rivalry in the Economics of Data, whose abstract opens, data is non-rival. But this is not just a one-off claim. There are lots of instances of arguments and approaches and models in the economic literature, but also in other literatures and in society more broadly, taking a really sort of strong stance towards data as a non-rival good. And it's not that surprising. We keep hearing about the data fire hose. There's so much data out there. It has so much potential, so much possibility. Our intuition is that data should have more in common with digital music than with an Apple. And the hope is that data can and should be freely shared and used and reused, and then we'll get more discoveries and more understanding and solve more problems. And I'm not against data sharing and data use, but I want to argue that at least in certain contexts, caution is warranted. So I want to make this argument, as I said, from three different perspectives: the economic, the privacy, and the statistics. These are going to be separate arguments, one after the other. I don't claim that every situation in which you are interested in using data fits under all three of these contexts, but I would like to think that at least one of these contexts is probably relevant to at least some situations in which you are interested in data use. So let's begin with the economic perspective. The story here is that, as we're all aware, over the past few years, AI has transformed data from plentiful to scarce. We went from that data fire hose, there's so much data out there, nobody's ever going to be able to capture or use it, to what felt like almost overnight, getting these sort of scaremonger headlines, AI companies running out of training data after burning through the entire internet. And we see this vibe not just in sort of scaremonger headlines, but also in research papers. I mean, now that we've figured out the technology to harness all that data, human data creation doesn't seem to be keeping up. Of course, this trend could change. There are lots of question marks. It's hard to model. But we get things like this article. I'm not endorsing any one particular analysis of this, but there's a lot of this out there. Will we run out of data? Under various modeling assumptions and various sort of projections, trying to figure out, when high-quality data of various types is no longer going to be catching up with our need to train new models. And so the sort of claim here, which I think is actually not that provocative at this point, is that scarcity of data, that we have a real new scarcity of data for AI. And the next step is that that scarcity makes it more rival. And the theory here is that in the nearest term, tech companies are going to live or die by their AI edge, or at least they seem to be acting that way. And one way to get that AI edge, not the only way, but a pretty important looking way, is by having more data or better data than your competitors. Now, if there were an infinite supply of infinite sources of data, data wouldn't offer an edge. But in our reality, once a competitor gains access to a data set, it potentially becomes less useful to you in this space, which is not the kind of thing you'd expect from a non-rival good. So where does this leave us? The sort of natural prediction, which I've been saying for long enough now that I've already had time to sort of see it coming to fruition, is that rivalrousness will breed an excludability panic. What do I mean by that? That we'll start to see more and more that, of course, data has always been excludable, but now we're going to see much more instances of data hoarding, buying with exclusive contracts, and these kind of funny strategic regulation games, situations where all of a sudden a company starts to care about privacy so they couldn't possibly share their data with others, or these sort of attempts to hobble regulation that would promote data sharing or data portability. We see lots of sort of maneuvering in these kinds of spaces. But, I mean, companies need these new models, data sellers need these new models, society needs these new models. We're kind of in an interesting situation, and it brings a lot of questions and a lot of opportunities. Some of those questions are things like, if data's rival, then how are we going to start to think in a more nuanced way about the value of data and the kinds of transactions that we want to enable or carry out around data? What are the kinds of rights that we want to buy and sell? How do we value those rights? Other questions are questions about incentives. How do we build and keep incentives to generate new data and to ensure that we get the innovation and the competition that we believe is enabled by that data? And also, so if we're really running out of data, what else is there? What replacements do we have? Not just how do we make our algorithms more data efficient, but also to what extent can synthetic data bridge the gap? What do we want from our synthetic data? What are the limitations? What are the fundamental sort of limits of what we can do with this resource that we have? Because we all of a sudden have to squeeze as much as we can out of the data. That was one perspective. Clean slate, new perspective. For the next few minutes, I want you to pretend that privacy is something that you care about, or at least that you've been forced by regulation to act like you care about. And I'd like to argue that, even if you really don't care about privacy, if you do care about that previous problem that we need lots and lots and lots of data to train our models, then you kind of sort of have to care about privacy at least a little bit, because we're going to have to train those models at least to some extent on some pretty personal private data. Okay, but you care about privacy now. Over the past couple of decades, in the sort of principled study of privacy, there's been this revolution. You've surely all heard the term differential privacy, a notion that comes from work of DeWork, McSherry, Nassim, and Smith from 2006. I'm going to talk very briefly about differential privacy, but the real guts of the concept and all of the algorithmic insights are actually not key to the argument that I want to make today. But just briefly, what does differential privacy allow us to do? It's this formal mathematical vocabulary for exploring what are the trade-offs involved in the intentional release of aggregate information versus the sort of potential harms or disclosures about the underlying data. There are lots of models under which we can obtain these kinds of guarantees of differential privacy, so protecting the underlying data while releasing aggregates. We know how to release aggregate statistics. We know how to train machine learning models. We know how to answer requests that have been formulated over time by various actors. We know how to create synthetic data that respects key aggregates of the true underlying data. We know how to allow individual data providers to provide their own privacy by giving perturbed answers to requests about their data. So there are lots of models, lots of things we know how to do, a very rich algorithmic vocabulary that's been built up over the past couple of decades. What's the basic idea of the guarantee? It's a kind of stability guarantee. Differential privacy is a constraint that says that your algorithm should behave similarly when it's handed similar data. Okay? A little bit more specifically, if you have any two databases that you might input to your algorithm that differ by the addition or removal of one person's information, then we want to say that we're going to get similar outputs. But we want a notion of similarity that's going to be meaningful sort of for a very broad range of output types. And so somehow we want this notion to capture the intuition that any one person's data couldn't have affected the outcome of the algorithm by very much. And therefore, intuitively, by looking at the outcomes from the data, looking at the trained models or whatever it is that comes out of your algorithm, you don't learn very much about who was or was not in the data set. And the goal is to get these kinds of guarantees while still retaining the important, interesting things about the underlying data, whether there's trends, aggregates, things like that. So formally, we say for any D&D prime that are identical sets of rows, except for the additional or removal of one person, we want to constrain the behavior of this algorithm to have a particular similarity property on the outputs. So in particular, the probability that we produce outputs from a particular set should be very, very similar under these two input data sets. We've got lots of ways to achieve differential privacy at a high level. You can perturb the data, you can perturb the algorithm, you can perturb the output of the algorithm, and you can do other stuff that looks like none of the above. We have a really rich vocabulary. The part of this literature that I actually want to put my finger on, though, for giving us insight into how we think about data is actually sort of the parallel literature. Not the algorithmic literature so much, but the literature that's grown up alongside the algorithmic literature on lower bounds. This is a literature that has started to teach us about what's possible or impossible really under any reasonable notion of privacy, not just differential privacy specifically. And there's some key lessons that come from that literature, and one of them is that privacy harms add up, period. What do I mean by this? Well, I mean, every aggregate statistic, every output you obtain from some analysis of a data set is intuitively a constraint on the underlying data that could have generated that result. And so, without any noise on these constraints very quickly sort of corner the possible data set. There are various things that we can say technically, but maybe we don't need to get into that. But the point is that even if you then go and perturb those results, you perturb those statistics, you perturb the computations that you do on the data set, even then, they still form a noisy constraint on the underlying data. And even with noise, even with the cleverest possible algorithms and the best privacy technology out there, privacy harms unavoidably accumulate. And this leads us to sort of what I think of as the mindset of differential privacy, which isn't really deeply tied to the specific notion of differential privacy, but it's sort of a fundamental truth. These privacy harms necessarily add up across data users, across data sets. And this leads us to think about data and privacy in a slightly different way. It leads us to analogies like a privacy budget. So if I want to guarantee that you have privacy across all of the computations that will be done on your data, then I need to think about each of those computations as chipping away from some privacy budget that you have. And at some point, the budget is gone. And so the implication is that privacy concerns, when they're relevant, should make data more rival. And this is really a very broad statement. Every computation on a data set that has downstream visible consequences is a privacy leak in some sense. And even with the best protections that involves some harm to privacy, there's unavoidable accumulation. And so if we want overall meaningful privacy, all of a sudden, my use of data over here and my use of data over there, or my use of data over here and your use of data over there, have some new interesting interaction with each other. Every computation is in some sense a foregone alternative computation. We have to be negotiating over who gets what at what level of accuracy if we want overall privacy. And that's really fundamental and unavoidable. Your use of the data set harms my ability to use it. So this rivalrousness that emerges in the context of privacy induces, again, some new questions, the need for new technologies. If the privacy harms are adding up, then maybe somebody's got to track them. Who's supposed to be tracking them? When and how and in what context? All of a sudden, it produces more thirst and need for learning algorithms and learning infrastructure that's maybe strategically and selectively using data and reducing our use of data. And also, if potential users of data are competing in some sense now over the same privacy budget, that introduces a need for new mechanisms for deciding whose computations at what level of accuracy are going to get done. And we've seen this play out in the real world, for example, in the context of the US Census. So some of you are probably familiar with the census story, but every 10 years, the US has to publish sort of a national census with data about everyone who's living in the country. Up through 2010, the way that the releases based on this data were protected was a secret based on sort of the best available understanding to statisticians. After 2010, the census did some sort of introspection and realized that those releases were actually allowing reconstruction of the underlying data, whoops, and started to introduce differential privacy technology in the context of the 2020 census. And one of the many things that this has induced is an all-out brawl around who gets what computations with what level of accuracy from the census. Because all of a sudden we've had to reckon with a truth that was always there. If we cared about privacy, then we needed to be negotiating about what computations we do on data, but all of a sudden it was made explicit, and that was super painful, and we haven't figured out how to navigate it well. Okay, third perspective. So forget about privacy. You don't care about privacy anymore. What you care about is science. You care about doing good science and doing it well, and I mean in particular you care about doing data-driven science. So science is an adaptive process. What do I mean by this? I mean, we don't go and ask all the questions. What we do is we explore some things, we learn some things, and then we go and ask other questions that are inspired by what we've learned so far about the world. So maybe we notice some pattern and we go explore it. Or maybe we read a paper that some other team has published and it gives us an idea and we follow up. Maybe we see something interesting going on and we try to leverage that phenomenon, sort of dig deeper. There are lots of ways that adaptivity shows up in our scientific process, and adaptivity is wonderful. Adaptivity is absolutely necessary for scientific process because we cannot and we do not want to ask all the questions. We want, in some sense, to explore the tree of possible scientific discovery in a smart way. And when something we research over here tells us those questions are no longer interesting or important, we want to ignore them and go over and ask these questions instead. So adaptivity is great, it's essential, and it also can get us into a boatload of trouble. So we've seen this trouble cropping up over there in the social sciences. Maybe you've heard about the sort of reproducibility crises of many of the data-driven social sciences, where many, many prominent data-driven discoveries, whoops, don't replicate when we go back. And there are a lot of reasons for this, but one of the reasons that has been implicated for this crisis in the data-driven sciences is adaptivity. Now, this adaptivity problem is cropping up because intuitively, if you're adaptively picking which question to ask next, you can accidentally discover questions that are anomalous on the data sample you have at hand and don't replicate on the underlying data distribution. But it's not just a problem of those guys over there in the social sciences who don't know how to do their statistics. This is a problem that shows up in our own backyard in various ways. Many of you, of course, are familiar with Kaggle competitions, and maybe you already know the phenomenon where, what's the concept? Kaggle competition, I got a lot of data, I want to get people to compete over creating a better model. What am I going to do? I'm going to divide my data into 3 pieces. First piece I'm going to put out there in the world and say, hey, go play with this, do whatever you want to with the first piece of data. Second piece of data I'm going to use to run a leaderboard while we run our competition. So every now and then you can submit your best model, I'll give you a score based on the second piece of data. Third piece of data I hold out and I save, and I actually use that to give out the prizes at the end of the competition. Many of you have probably heard people manage, despite all incentives to the otherwise, to overfit to the second piece of data, which they do not have in their hands. Okay, so what's going on in all of this? Repeated adaptive use of the same data can mislead us, and it can mislead us very fast and very seriously. It allows you to unintentionally focus on quirks of the data sample that don't manifest on the underlying data distribution. And the important point is that it's really adaptivity that's driving this issue. If we don't have adaptivity, science on a sample works. This is kind of an obvious statement, but it's still kind of amazing and profound how well science on a sample works. I've got some data distribution, I grab a small sample, and take a simple Chernoff bound and a union bound, and boom, you can answer an exponential number of queries and get good answers on all of them on your sample. That's super amazing, right? And then you bring in adaptivity, and all of a sudden, what? You can mislead yourself on the second question. So we've got this huge disconnect. Adaptivity breaks something very fundamental in science for us. And the question is, what are we supposed to do? How are we supposed to do science on a data sample? Because we still really want to do science on a data sample, and ideally without fully abandoning adaptivity. One solution, of course, is abandon adaptivity. Don't reuse your data. What's the real problem here? The real problem here is with data reuse. If I do science over here on one data set, and then I think really hard, and then I gather new data and do science over here, that's fine. I don't have my adaptivity-driven overfitting problem. But as soon as I'm reusing data, which we really, really would like to be doing, then I can get myself into trouble with adaptivity. If we're not reusing data, your database size is growing linearly with your number of adaptive rounds. Not so nice, especially in situations where data is expensive, hard to gather, or really impossible to gather. My favorite example being, we will only ever have one World War II as far as I know. So if you want to research it, you're stuck with that data. Okay, so here we can start to talk about how can we model this situation in order to get our hands on what's really going on and how we might mitigate these concerns about adaptivity-driven overfitting. So we might talk about, we've got a data domain. People are going to have access to a particular data set of size n that's drawn from some distribution on the data domain. And now they want to do some science on this sample. So what's the way to think about this? I've got my database, and I'm going to be getting in queries Q to my mechanism, and I want to return responses R. Where are those queries coming from that lets us sort of draw the adaptivity into the picture? Well, there's going to be some A. Maybe it's an adversary or just an analyst who's going to be looking at the results of my previous queries, and they're going to be generating new queries. So now we have this interaction between the M and the A. This is supposed to be sort of a very simplified model of adaptive discovery. And then we can think about this as sort of all going inside a box. So what we really want is the ability to take an M and an A and have them interact in a way that gives us reasonable results. Or again, that data sample is drawn from some distribution. So for the purpose of stating something semi-technically, let's focus on the class of linear queries as things that we want to analyze on our data set. We could talk more generally if we wanted to. And the question is sort of what do we want from this interaction between the mechanism and the analyst? So one thing we might hope for is some notion of alpha-beta accuracy. So the answers that we give to the questions on the sample should be close to their true answers on the sample. But we might also hope for something bigger, that we're really doing science that has to do with the real world. So we might hope that the answers that we're giving are actually close to their true answers, not just on the sample, but on the underlying distribution. So a recent line of work that was initiated by work of Dwork, Feldman, Hart, Patesi, Reingold, and Roth starts to give us some sort of new vocabulary and tools for understanding adaptivity's harms. We now can sort of mathematically, formally point to what's going on and what's going wrong in order for adaptivity to mislead us. We can say it mathematically. We can also say it informally. Maybe I'll say it informally for now, which is that there are two things need to happen in order for adaptivity to get us into trouble. They're very simple, but this is it. I mean, this is sort of a fairly high fidelity English language version of what the math says, which is that previous queries' answers have to encode a lot of information about the sample, as opposed to the distribution, and then subsequent queries have to go and leverage this information. That's it. That's what's happening to get us into trouble. And so you can see, if you want to protect yourself against getting into this kind of trouble, you have a couple of places where you can intervene in the system. So some of what we've gotten from this line of work over the years is not just this understanding of what's going wrong, but actually some mathematical tools that let us intervene and do adaptive science in a way that gives formal guarantees that we're not going to have this overfitting problem. Sort of high level of how these arguments work What are we trying to do? Well, we're in this world where our goal is to give answers at the top that are good on the underlying distribution. What do we actually know? We actually know the answer on the sample, and then we have a choice of what we actually reveal. We don't have to reveal the answer on the sample. We can add noise to it, or we can do other stuff with it. We can say something else. But our goal is to say something that's close to the truth. So that's what we say. That's the truth, and that's what we know. And we want to somehow play with this triangle inequality, and you can name the various relationships between these things in this space. And one way to summarize the results that we have in this space is that you can write another version of this triangle inequality with some other concepts that are a little bit weirder, that involve sort of thinking about some sort of query on some posterior induced distribution. But the really cool thing is that then, sort of surprise connection, the toolkit in mathematics of differential privacy ends up being actually very relevant and useful for getting these kinds of relationships and these kinds of guarantees. And intuitively, what's going on here? I said differential privacy is a stability notion. What do you want from privacy? You want to learn general stuff that's true about the data that doesn't reveal too much about any one individual. What do we want when we want to do science? We want to learn general stuff that's true about the underlying distribution, and it's not very specific to the individuals in the data set. It's bad science if your results would have been different had a different person showed up for your experiment. And it's very, very similar at some level to privacy, although the analogy is not perfect, and that gap in that analogy is one of the fun places to play in this space. But the important lesson for us is that adaptivity makes data more rival. Every computation reveals more information that could be specific to the data sample we have at hand, as opposed to the distribution. And these revelations, in a sense, add up. And so if you want to protect yourself or protect the world from being misled and asking overfitting queries, then in some sense, data carries with it a statistical validity budget that's gradually spent with every query. So in some sense, your use of the data can mislead me and degrade this budget, which is not exactly the kind of thing you'd expect with a non-rival good. So again, we have this, sort of gotten ourselves into a bind where all of a sudden we can't just use all the data as much as we want to, but for another reason. And now we have potentially a need for new infrastructure, for tracking data uses within or across groups, or maybe protecting ourselves formally against adaptivity-driven harms, or detecting them before they get us into trouble. And there are interesting scientific questions to ask about all of these things. Now, in parallel to all of that, we have what's really going on with data in the real world. And one of the things that's going on with data in the real world is a large amount of regulation, particularly in the European context, that tends to really deeply misconstrue the nature of data. One of the things that we see going on in not just the European context, but strongly also in the European context, is this tendency to think of data as being something that we can use to fight against sort of competition concerns. So if I'm worried that one big company is getting kind of a monopoly in some space, one way to solve the problem is just making sure that everybody else who wants to compete with them has access to their data. Potentially gives us some partial solution to this monopoly problem, but as we realize, as we think about data as a rival good, potentially raises a whole host of other issues. But we also see problems with sort of the general conception of data and strategy for data broadly in the European data strategy, where there's a lot of emphasis on sharing and reuse, potentially in many cases by a really diverse and sort of wildly sort of uncentrally regulated and supervised set of bodies. So specifically in the context of the Data Services Act, which is regulation that sort of tries to keep an eye on the behavior of these very, very large platforms and providers, provides provisions for researchers to get access to data in order to check that these large platforms are not misbehaving. But there's really no reasoning or thinking about, controlling where this data is going and the consequences of this sort of extreme new venue for getting access to data. In the context of the Data Governance Act, which is really focused on increased sharing. Again, it develops all sorts of means for lots of people and lots of organizations to get access to data, but without a lot of thinking about the downstream consequences. So in summary, recent sort of advances in 3 fields bring us to think about data as being rival for a variety of reasons, a variety of types of data. And one thing to take from this, from my perspective, is that perhaps data is sometimes best thought of as a resource that's depleted as it's used. And that's a very unfamiliar way to think about data that has a lot of consequences. It has consequences that push us in the direction of reduction. Should we be building systems that are really thinking carefully about using only what they need in terms of data? Sort of like when you, in your hotel room, there's that little sign on the wall that's asking you to minimize your electricity and water usage. Do we need to be thinking similarly about how do we minimize our data usage? How do we minimize its spread? How do we think about the use of alternatives and synthetic data, and what is their role and what are their limitations? It introduces the potential need for some really awkward coordination amongst users of data. Because if my use of data impacts you, then maybe I need to be aware, and you need to be aware, of how the others are using data. Maybe we need some explicit tracking, some explicit coordination, maybe we need negotiation, maybe we need some centralized party that's going to say, yes, you go and you don't get to use the data. This is a really difficult thing, particularly if you're somebody like me who cares about privacy, because it feels like it's creating a whole new sort of big brother structure looking over our shoulders. But it's hard to see how we're going to get out of some degree of awareness and tracking, and there's going to be, I think, an interesting dance to be danced around sort of how do we navigate this. There's also a question of to what extent we need to build new replication infrastructure to allow for more robust science. And there are also big questions around incentives. How do we change, in the context of science, the publication incentives to address some of the concerns that we have about data-driven science, but also how do we create other incentives that are going to allow us to navigate this sort of data degradation in various contexts in the best way possible? And how do we make sure that we do all of this while still supporting the innovation and the competition and the many, many other things that we want data to enable? So I will leave it with that, and I'd be glad to take your questions. Thanks.
Thank you, Katrina. I don't know if you guys can still hear me.
Yes, we hear you.
Okay, great. Well, Ankur in the room is going to handle the QA, but while Ankur, you set up, I thought I'll just start with my question for Katrina. Very, very interesting talk, like thinking about all these different dimensions of data as rival good, non-rival good. You briefly touched upon this, like, I'm not sure if it's right to call it data also as public good in the sense of what the EU regulations are doing. What I was wondering is is your takeaway that such initiatives are misguided and problematic, or that maybe there's a more nuanced perspective that yes, for antitrust and and for better competition, we do need these public data sources, but maybe we should be really thinking about them as also being paired with incentives to replenish them. Just kind of wanted to give you an opportunity to maybe unpack that a little bit more as to, like, if you were to actually make recommendations, not just about thinking about budgets and control, would you be thinking about what it means to replenish these data sources for public consumption?
Yeah, I think this is a really great point. I completely agree that publicly available data is incredibly, incredibly important and powerful, and I don't want to argue against it. But what I want to argue is for an approach that comes with the kind of thought and caution that I think you're hinting towards. We need to understand the trade-offs that we're making when we decide to make data publicly or widely available. And maybe we do need to build infrastructure to make some hard decisions about, does a widely available really mean a free-for-all, or do we want to think carefully about which uses we want to prioritize, which ones are most societally important, and how do we build things like you're suggesting, infrastructure and incentives so that we replenish these data resources if they're being depleted over time or becoming less valuable or useful or relevant over time. And I think that that's really the sort of important set of conversations we need to have. It's not no, public data is not important, it's not valuable. Obviously, it's important, it has a lot of potential, but if we do it wrong, it potentially causes harm and doesn't realize its potential. And so that's the space where we have to encounter some uncomfortable questions about who decides and who gets what and who has what responsibilities. Thanks.
Thanks.
I can go next. I'm on your left. This is about data as a rival good in the context of adaptive data analysis. If I understand correctly, the issue arises when subsequent queries depend on results of previous queries, right? And I was wondering, you don't expect rival companies, for example, to share answers to the queries that they have asked. So I was wondering if adaptive data analysis is perhaps pessimistic here, and maybe you could take advantage of it to prove.
Yeah, absolutely. So I think this is one of the interesting challenges, both in the adaptive data analysis space, but also in the privacy space, is that the models that we do have are, in some sense, worst-case pessimistic models. And they may not match the real-world context in which we are really interested in data use. But it's been very challenging to come up with useful, formal, rigorous models that are less pessimistic. So I'm with you entirely, and I don't know that these pessimistic views need to dictate every move we make in this space, but they're currently the only rigorous tools we have for gaining understanding. But that gap is a really painful gap, and it's a really interesting and potentially fruitful gap. I totally agree.
What does the survival perspective say for the prospects for people who contribute data to have some kind of bargaining power or leverage or compensation for how their data are used? And this in particular comes up when we think about data, as creative work.
Yeah, so this is a really great question. So in some sense, you might expect this sort of rival nature of data to be good for the data creators, because data is being spent all the time now. We're going to need more and more of it. But the reality of the infrastructure that we have around data today is that we don't really have robust incentives and compensation for data creation in many contexts. And so we end up with these kinds of tragedy of the commons kinds of outcomes in some situations. One might hope to try to build some more infrastructure to reward and protect individuals in various ways. One of the things that comes up very quickly when you think about this, though, is that any one person's data, the marginal value is, in most contexts, extremely small. It's sort of only once we build that collective of a large amount of data that really tells the story and gives insight that it's really a valuable object. And so maybe the point at which you want to sort of bring people together to think about data rights and negotiating over value is not at the individual level, but at the collective level, which raises a whole host of other interesting questions.
Thanks.
Katrina? Is there another question?
Yeah. Katrina?
Yes.
Hi.
Hi.
Hi. So very thought-provoking, and I want to. So with the privacy and adaptive data analysis, there's definitely a cost there. I have some questions about that too, but I want to push back a bit for the first point. And I'm wondering whether the rival good here really is the data or the innovation in some sense, because you said that if the data was already used, it's now less useful for training another model. And I don't think so. I mean, it's possible that my business advantage as a latecomer would be less, but I'm not sure why that should be attributed exactly to the data. And again, it's the same thing as thinking that thinking is a rival good, or that innovation is a rival good. And I'm wondering whether it's really useful whether we should really separate between data as it's used, which is not rival, in business competition, which is kind of almost orthogonal, to and why we need to kind of wrap these together. And
Yeah.
Okay,
Maybe let's take that one, and then if we have
sure.
time, we can do another one, if that's all right. Yeah, I think it's a really great and subtle point that I, at least for myself, have not fully teased out. But I think you're right. We're in one of some of the writing we're doing around this, we spent a bunch of time really playing with this question of, are we talking about data, or are we talking about data use in particular contexts, and what is the importance of the distinction and these sorts of issues. But I think you're absolutely right that it's entirely possible that there's some uses of data that don't interfere with other uses of data, including in the sort of AI and model training context. But what we're seeing is sort of a sudden spike in many, many very, very similar types of models and uses of the data that do potentially interfere with each other in terms of our ability to gain sort of competitive advantage.
Can you give examples?
I'm just, the many companies that are trying to sort of win the race around various models for various particular objectives are in some sense fighting over who has access to better data, richer data, exclusive data. From the negotiations within Google, there was a lot of thinking about who has what data and these sorts of issues. And so it's true. It's, in particular contexts, and it's a little bit subtle to point out, where you want to put the word rival and what the consequences are. But I think one of the consequences is this sense that all of a sudden we're fighting over data in a way that we weren't before.
Yeah, I guess my thing is, if you already used your data to train your model, now I use mine, it's going to be just as good as if regardless of whether you used it or not. I mean, maybe I'm going to be in a business disadvantage because I did it later, or you want to prevent me, block me out of the market. But I'm having a hard time seeing how
the model is not worse, but it's about
the model itself is going to be just as good.
The model is going to be good, but the competitive advantage is in some sense the thing that's degraded. And I agree that that's a subtle point that needs more explanation.
So a more technical question about the privacy. I'm curious if are there ways to release data in a private way so that reusing it multiple times for different uses would still only have a fixed cost in terms of privacy?
Yeah, absolutely. So that's the sort of beauty of synthetic data. So if in a differentially private fashion I generate a synthetic data set, the beauty is that then anybody who wants to can go and use that synthetic data as many times as they want to for as many different computations as they want to. Privacy is not further harmed. The sad thing is that I had to, in order to make sure those downstream uses were good, I needed to anticipate those uses and sort of bake them into my generation of the synthetic data. And if you come up with a clever thing you want to do with the synthetic data that I didn't anticipate, there's no guarantee it's going to be accurate. You doing that computation isn't going to harm privacy further, but who knows what results you're going to get and what they're going to mean. So that's sort of the attraction of synthetic data in many of these contexts, is it potentially gets us out of this rivalrousness bind because it allows us to reuse data for free to some extent. And so I think the questions around synthetic data are really rich and important.
Do we know if this is inherent, or just we don't have methods of...
Sorry, what is inherent?
The fact that when we do this private data release, it cannot necessarily be as useful.
Yeah, that's a overcomable obstacle that's fundamental. Yeah.
Thanks.
Yeah.
Thanks for the very thought-provoking talk. You introduced this definition. Sorry, I'm in the center. I'm raising my hand.
Where?
I'm here.
Sorry.
Yeah. Thanks for the very nice talk. So you introduced this definition of a rival good in this kind of very strategic way by saying, your use of the good harms me. That strategic aspect was very apparent in the first two perspectives you presented. For the adaptive data analysis, it was less obvious to me. I mean, if you are using my data set adaptively and you're making your own inferences from that, those inferences may be problematic, but I have there's no reason I need to use them. First of all, as I think one of the first questions kind of indicated, the rival company may not even release those answers, but even if they do, I need not use them. So I was wondering if you could give a specific example where you think that strategic aspect might come up and your use may actually, in this adaptive way, may harm me.
Yeah, it's a great question, and I completely agree that the strategic considerations are different in the different settings. And if it's adaptive, a data analysis setting, the problem is just, it's true, I could ignore all of the science you're doing on the same data, but that's not how science makes progress. I don't want to ignore your science. I would like to be able to learn from and build on your science. And so if I would like to be able to reliably build on your science, now I'm kind of in a bind because I don't want your science to mislead me, but I do still want it to inform the questions that I ask next. So it's a different kind of a strategic consideration, but in some sense, you're burning the data not for my, if I ignore you, but you're in some sense burning the data if I want to pay attention to the insights you're gaining and build on them. Yeah, so I agree, it's a bit of a different issue. Thanks.
One more question. Thanks again for a very thought-provoking talk. So one property of the data that maybe is not very well captured by the rival goods perspective is that, okay, it actually is extremely easily shareable. There's no kind of obvious rivalry in sharing, but its value is derived from exclusivity. In many contexts, not in all, sometimes it is, but a lot of it comes from exclusivity. I was trying to, if there are any examples maybe that precede like the way we use data these days, and maybe the closest that I can think about is something like information or some kind of business relevant like secrets or some kind of, basically some kind of exclusive information know-how for doing things. And I was just wondering if economists have made this parallel. How do they think about the sort of information as a good, and whether there's maybe some perspective from that direction could also inform their thinking or our role thinking about data.
Yeah, I think these are really great points. So as you were saying, in some sense, naturally, data tends not to be extremely excludable, but for a variety of reasons, including for the sort of rival aspects of data, we may have reason to try to build excludability around data. And I think you're right that the best parallel that I can think of in sort of other goods is around sort of information related to discovery and innovation. And there is an economic literature around discovery and innovation, and I think it would be helpful to try to mine that for some insights for us. I don't think the literature has done that yet, because the economic literature is not where I'm at in terms of thinking about data in this way. But I think that that's a really interesting direction to try to pursue. Thanks.
Thank you.
Are there more questions in the room?
Hi, over here. I'm not an economist at all, so this is probably a very naive question, but the data is not really consumed in the process of making a model, like it's been pointed out. So I would have thought it would be more logical to view it as a form of capital. Do you have like a sort of intuition for what distinction this makes relative to regulation?
Yeah, so the data is not literally disintegrating. You know, the bits are not disintegrating. But depending on the context in which we're speaking, our ability to gain value or enjoyment from them is in some sense disintegrating. So it's a more abstract thing that is disintegrating. It's not like I'm eating the apple and it's disappearing. The data is still there, but for example, in the privacy context, there's a limited privacy budget, and that budget is disintegrating. And these are the kinds of points that I want to dig into. So we can definitely have rival goods that are durable and rival goods that are non-durable. And that sort of distinction was already present and well discussed in the literature. And I think the subtlety is it's not literally always the data that we're talking about here. Somehow it's types of uses of the data, or sort of a concept that's associated with the data that's being spent. And I think there's room to dig more into some of these subtleties, as you suggest.
Yeah, thank you.
Thanks.
Okay, so let's thank Katrina one more time.
Thank you, Katrina.